Good afternoon, students. Today we're going to look at the scientific revolution. Now you've got a little bit of an intro, okay, and then afterwards there's a little bit more of videos that you're going to watch afterwards to kind of further draw the point in regard to how the scientific revolution was really a revolution. We are changing the thought here of how people see the world, and this is a big thing. I've always told you about how when you're changing mindset, it's a tough job, and once it starts, it's really hard to move people's mindset. It doesn't happen overnight. It's a really tough job. And so these gentlemen who want to change the way we view the world, literally, it's a tough job for them, and they're going to face some really hard life choices because of it. So let's get going. All right, the Renaissance and Reformation led to the scientific revolution, and the reason why it did is because there's a gradual progression of these things that led to the scientific revolution to happen. So let's follow. We talked about the Renaissance. The Renaissance we know is a rebirth of knowledge of the classical civilizations, which led to humanism, a study of non-religious subjects, and the realization that man can think and discover a knowledge apart from the direction of the church officials. Remember, before the Renaissance, the church basically told you if the sky was blue, you believed it. If they said the sky was purple, you were supposed to believe it. The Reformation, though, further challenged the authority of the Church, which had been the only source of knowledge and education since the fall of Rome. Once we start having people say, nope, the sky isn't purple anymore and the church is wrong, I don't like this church, I want to start my own church or my own way of thinking, that changes, it starts the ball rolling down the hill. With the printing press, and we talked about what the printing press brought, the common man could have books in his hands written in vernacular, language they understand, everyday language, like English, German, French, or etc., instead of Greek or Latin. So now it's more common. Okay, everyone can understand it. As man began to read for himself, he began to think through common truths, put forth by the church and believed by the general population. All of this led to people in the Renaissance and the Reformation era asking new questions and seeking new answers apart from the authority of the church. Instead of saying, the church says the sky is purple, I should believe it, they start saying, why is it purple? They're not actually questioning the church's reasoning. They're saying, but why? I want to know why. Sort of like the 2-year-old. Why? Why? You know, why? They just want to know why. These questions led to new understandings and changing views about common knowledge. Some of these first changing views had to do with the basic ideas of how the world works. And this is the biggest change right here, is the changing view of the universe from geocentric to heliocentric. The commonly accepted view of how the universe worked was proposed by the Greek astronomer Ptolemy and accepted for over 1,000 years. However, once again, this is a Greek astronomer. His idea was that Earth stood still in the center of the universe and everything else revolved around the Earth, just like in the picture. This idea was sanctioned and approved and supported by the Church. Today we know that this is not true, that the sun is the center of the universe and the planets revolve around a still sun. However, in the times of the Renaissance and the Reformation, people still believed in Ptolemy's heliocentric world. That is until Nicholas Copernicus and Galileo Galilei came along. Nicholas Copernicus was a Polish scientist, but he was also a monk. So he's not really going to, he is also a monk too. And he's going to use his knowledge, because we know that monks were very well educated, to start asking why. And so he proposed in 1543 that the Earth was not the center of the universe. Most people ignored his theory because he did not offer enough substantial evidence. Also, the whole system of human knowledge was brought into question. He is important as the first person to challenge the church and common knowledge. Copernicus and his model, sun-centered with planets revolving around him, was the heliocentric model. So we know he wants to change it, because if you question how human life started, and whatever you believe is whatever you believe, but this is what he was saying, and that challenged it. challenged the church. Galileo Galilei was an Italian scientist of the early 1600s, was able to offer proof that Copernicus was correct. Galileo built a telescope, and with it was able to observe and record proof that the sun was the center of the universe, not the earth. Galileo, like Copernicus, was not really accepted either. In fact, Galileo was put on trial because the Catholic Church Inquisition and was almost killed because of his discoveries, yet he was given reprieve and put on house arrest. Then comes the scientific method. Even with all the opposition of the church, scientists continue to question the way the world worked. They really start to challenge it. Two key scientists, Francis Bacon of England and René Descartes from France, made giant leaps of knowledge during this time. We credit these men, among others, with the development of the scientific method, a revolutionary idea of how man acquires knowledge based on observation and experimentation. The scientific method, you are probably already familiar with this process from any science class you have taken. First, you choose what you're going to observe. You identify a problem with it. Then you research the problem. Then you develop a hypothesis. A hypothesis is like a guess to the solution. What will happen? Then you design an experiment to test your guess. After you test your guess, you analyze the results. Then once you analyze your results, you formulate a conclusion. This might take you back to step 2 again, because if your conclusion was right or wrong, then you have to see if it works again, and that's why they do it again. Okay? They want to see if their hypothesis is correct, and in order to see if it's correct, they have to be able to get it to do the same thing over and over and over again. That's the only way you can prove whether or not your hypothesis is correct. So, why is the scientific revolution so important? Well, the major advances that occurred in the scientific revolution began in the 1500s, have changed and shaped scientific and technological knowledge for the last 500 years. Much of the knowledge discovered by the thinkers of the scientific revolution are still taught in science classes today. You definitely learn about the scientific method. Overall, the scientific revolution made it apparent that there was a vast world of knowledge to be discovered, and that commonly believed truths could be questioned and found incorrect. This would lead to the age of exploration and the Enlightenment, two other topics we're going to talk about later on. So let's focus down even more. Causes and effects of the scientific revolution. Causes: exploration and expansion of trade, continued study of ancient theories, and development of the scientific method. What are the effects of those things? The beginning of modern science, the belief in progress and the power of mind and reason, and now new views of the universe as well as a well-ordered system. So those are the impacts of the scientific revolution. This is the end of our presentation. You will have a few more things to look at after this, another video about Copernicus, and then we will continue on the next day with some more videos. Okay? If you have any questions, you know where to find me.